Today we have a training for champions. As usual, we will solve 3 advanced problems from AMC. So, for k greater than 0, let ik be the number 1, 0, 0, 0, 64, where there are k zeros between 1 and 6. So you have k zeros here. Let nk be the number of factors of 2 in prime factorization of ik. What is the maximum value of nk? Well, perfect. Here we are looking at the number that look like this: 1, 0, 0, 0, and 64. Of course, it can be represented as just 1 with several zeros plus 64. And just remember that by the condition we have here k zeros, and if we separate 64 like this, we will have k plus 2 zeros here. If we have only 1 zero here, it's 10 to the power of 1. 2 zeros, it's 10 to the power of 2. K plus 2 zeros means that the first number is 10 to the power of k plus 2 plus 64. Okay, we are looking for the maximum power of 2 that divides ik. Really, we are looking here at the prime factorization of ik. So ik can be represented as product of prime numbers in different powers. And some of these prime numbers obviously is 2. Really, this number, ik, you can see it's obviously even, and of course it's divisible by 2, right? So in the prime factorization of ik, there will be some power of 2 here. And we are looking at the number of factors of 2. So the number of factors of 2 is this number p. It's just how many 2 are present here. And we are looking for the maximum value of p. In other words, we are looking for the maximum power of 2 that divides ik. And this is it. Of course, it depends on the k. We are looking for the maximum power of 2 that divides ik, and it is like our main goal to find it. So let's understand what power of 2 is present here. You obviously noticed that 64 is a power of 2. It's 2 to the power of 6. This one also is divisible by 2. 10, and it can be represented as 2 times 5 to the power of k plus 2 plus 6. And you can see here we have the expression 2 to the power of k plus 2 times 5 to the power of k plus 2 plus 2 to the power of 6. And it obviously contains like powers of 2. And of course, if k plus 2, if this number is less than 6, then you don't have like a good result, because, for example, if this number is 4, then the maximum power of 2, which is present here, is 2 to the power of 4. So we're not interested at this one to be less than 6. We're interested that this one is greater or equal than 6. Well, in this case, 2 to the power of 6 is present for both summands, and this one is divisible by 2 to the power of 6. And at least we can tell that 6 is just a possible option for p. So let's separate it. 2 to the power of 6, 2 to the power of k minus 4 times 5 to the power of k plus 2 plus 1. Okay, so here is our representation of the number ik. And it looks like here we should tell this number is even, because 2 is here, plus 1, it is odd number, so no powers of 2 are present here, and we multiply it by 2 to the power of 6, so this one contains 2 to the power of 6 as a maximum power of 2. So, but it's like a tricky moment, very important thing. This idea that we told now, it is true if you have real number 2 here. It means that k plus 4, this power, should be at least 1. It's greater or equal than 1. But in our case, it's very important to understand that it may be not the case. For example, for k equals 4, this power is actually 0. So you can't claim that this is an even number here. If this is 0, for k equals 4, we have a number here in parentheses 5 to the power of 6 plus 1, and as you can see, odd, it is an even number, a sum of odd numbers, and you have additional power of 2 from this sum, and it is like a tricky moment in this problem. Let's understand what is this value. It will be 125, because it's 5 to the power of 3 times 125 plus 1. And eventually, if we calculate the value, I will just save your time, and I will save my time. So I calculated that it will be eventually 15626. You can do it like by hand, right? 15626. So it's definitely even number. And the main question, how many powers of 2 will it provide us? Because if we divide it by 2, we will get 2 times, what is the value here? 2 times 7813. 7813 and 2 to the power of 6. So you will have this situation. And obviously, this number can provide you only one power of 2 here. It will be 2 to the power of 7. And this result is like odd number. So there are no powers of 2 here. So our conclusion, IK can be divisible maximum by 2 to the power of 7, and it happens in the case when k equals 4. And this is it. It is our answer, and it means that the maximum value of nk is 7. This is it. Let's go to the next problem. Okay, let's solve problem for champions number 2. It will be a geometry. So, Andrea inscribed a circle inside a regular pentagon and circumscribed the circle around the pentagon and calculated the area of the region between two circles. Okay, let's stop here. Let's just understand what's happening in this problem. So we have a circle inscribed in a pentagon. So let's draw a pentagon, and it should be regular, and we have an inscribed circle like this, and also we have a circumscribed circle, and we calculate the area of the region between two circles. So let me just mark here like circumscribed circle. Maybe it will be not a perfect one, but just something. So it is a circumscribed circle around this pentagon, so it passes through the vertices, and we calculate the area between two circles, basically the area of this ring. And after that, Bethany did the same for the regular heptagon with 7 sides, and the areas of the two regions were A and B. So basically the area of this region is A of this ring, the ring between two circles for the pentagon. And for heptagon with 7 sides, we will not make a picture, but just it will be B, if you calculate the similar area of the ring for heptagon, it is called B, and each polygon has a side of 2, so this side is 2, and the heptagon also has a side of 2. Which of the following is true? So you need to find the relation between area A of this ring and the area B of the similar ring for heptagon. Perfect. So let's not forget that this one is simply 2. Well, if you want to find the area of this ring, well, it's very simple to do. So here is the center of your regular pentagon. Obviously, the radius of circumscribed circle is actually this one. So you just need to connect the center of the pentagon with one vertex. And this one is R, capital R, is the radius of circumscribed circle. In the same time, the area or the radius of inscribed circle is this one. You just connect it with the midpoint. This is a perpendicular, the point of tangency, and this small r is the radius of inscribed circle. And if you want to find the area of the ring between these two circles, it's very simple to do. You just take the area of the big circle and subtract the area of the small circle, which is inside, and you will get exactly the area of this ring. So the area of the big circle is pi r squared minus the area of the small circle, pi r squared, which can be represented as pi r squared minus r squared. You can see, and what is r squared minus r squared? Well, let's look at this triangle. It is a right triangle. The side of our polygon is 2. Of course, this point of tangency is a midpoint, so therefore this segment is precisely 1. And by Pythagorean theorem, its hypotenuse square minus this leg squared, well, it's simply 1 squared in our case. So it will be pi 1 squared, which is simply pi. So here we see for the regular pentagon that the area of the ring that we are looking for, it is simply pi. Well, the main question, what will change for the regular heptagon if you have 7 vertices here? Well, if you just imagine the picture, everything will be exactly the same. The picture will be very similar. You will have a regular polygon with 7 vertices here, inscribed circle, circumscribed circle. You will still find the center. Center is just the center of a regular pentagon, of a regular heptagon. You can find this point is just the point of intersection of these perpendicular bisectors. So these lines, they divide our regular polygon into equal portions, and they intersect at the same point, which is the center. And the picture will be the same. So you will connect this point with the vertex of the regular heptagon. You will connect this point with the midpoint of the regular heptagon. It will be perpendicular, and you will get the same relation and the same equation. So this area will be exactly pi for the regular heptagon. Nothing will change. So A and B are exactly the same, and A equals B. This is it. Let's go to the next problem. Okay, let's go to the problem for champions number 3. Again, it will be geometry and an advanced problem from AMC. Convex quadrilateral ABCD has AB9, CD12, and let's make a picture. Okay, so NC, yeah, so convex quadrilateral ABCD. So ABCD. Okay, so let's mark A, B, C, D. AB is 9, CD is 12, and diagonals AC and BD intersect at E. So let's draw diagonals AC and BD, that the point of intersection here is E. Perfect. And AC is 14. Okay, so let's mark that AC in total is 14. Let me just use the same color, blue color, to mark AC. So this one is 14. Perfect. And triangle AED and BEC have equal areas. Okay, AED and BEC have equal areas. So these two triangles have same areas. What is AE? So basically you need to find AE. Let's mark it with the red color so we will know that this one is what we need to find. Okay, as you can see here, we have lengths of several segments. If you have basic experience at geometry, when you work with quadrilaterals, what means that, for example, two of these areas are equal? Well, from here you can pretty fast come to the conclusion that this side has to be parallel to this one. It's very simple to understand. If this area is equal to this area, let's add the area of this triangle to both of these. After that, you will get that the area of this triangle should be equal to the area of this triangle, really, because you just add two equal areas, the area of the same triangle CED. So if the area of this one is equal to the area of this one, then the altitude from A to CD, this perpendicular, is equal to the perpendicular from B to CD, really, because CD is the common side of these two triangles, and equal areas means that this perpendicular has to be equal to this one, and if these two perpendiculars are equal, it means that CD is parallel to AB, and this is it. And of course, it's a great time now to redraw our picture. So now here we'll have CD, and here we will have AB, which is a little bit smaller, so CD is 12 and AB is 9, and it looks like we have a trapezium here, right? So it is a trapezium. Here we will mark AB, here we will get DC as earlier. So we have here diagonals AC and BD, they intersect at the point E. In geometry, is absolutely normal story that sometimes you have to redraw the picture or you have to separate some part of the picture and draw it separately. It's absolutely normal thing. Okay, and now we know that diagonal AC equals 14, so that this one is simply 14, and you have to find AE. Well, now the situation is absolutely obvious. This one is parallel to this one, and therefore these triangles AEB and DEC, they are similar because these two lines are parallel. Let's mark equal angles, and we will write from their similarity that AE opposite to this angle, AE divided by opposite to the same angle in another triangle by AC, by EC, AE over AC, equals AB, which is 9, opposite to this angle, and opposite to the same angle in the other triangle you have 12. 9 over 12, which is, well, we can't reduce it, so we'll leave it. No, we can. So we will divide both by 3, and it will be 3 over 4. Perfect. So AE, we can denote it as 3x, AE is 3x, and EC is 4x. Perfect. So it means that this one plus this one equals 14. So 3x plus 4x equals 14, and from here x equals simply 2. And therefore AE, which is 3x, equals 6. This is it, and 6 is our answer for this problem. So now it's completely solved.